Okay, let's look at a proof where we actually use some of these perpendicular line properties that we've seen in the past. And I'm going to try to keep it as clean as I can, but no promises here, but we'll do our best. I think that I can give you a good model of what that could look like. Okay, so let me go ahead and I'm going to make two columns. And this isn't the only way to do proofs, but it is a way, and it's a fairly helpful way, I think. So on the left side over here are all of my reasons. Oh, that's not what I want. Here are all my statements. And on the right-hand side are all of my reasons. Okay, so with any proof, just to kind of get you thinking through the thought process of how we go through a proof, let's try to start from the end and work towards the beginning. So this is me just kind of brainstorming right now. I know that 1 and 6 are supplementary, so I'm just gonna give myself some space to work over here. I know that the measure of angle 1 plus the measure of angle 6 is 180. Okay. And yeah, that's not exactly what I know. I would have to show that. But again, we're just kind of thinking through. And I'm trying to prove that K is parallel to I. So what are some ways that we could show that K and I are parallel? Well, I know that 1 and 6 are complementary. If I could show that angle 3 and angle 6 were complementary, sorry, not complementary. I know that 1 and 6 are supplementary. So if I could show that 3 and 6 are supplementary, well, then I'd have alternate interior angles, right? And that if I know that alternate interior angles are supplementary, then I know that those lines are parallel. Another way that you could think about it is I know that angle 1 corresponds to angle 5. And I know that 5 and 6 are supplementary, right? Or at least that they add to 180. So if 5 and 6 add to 180 and 1 and 6 add to 180, then I could do maybe a little bit of transitive property there to show that the measure of angle 5 is equal to the measure of angle 1. And then by corresponding angles, I could show that these two lines are parallel. I think it might be a little bit easier to do this. To show that 1 and 6 equals 180, to say that because of that, and because 1 and 3 are congruent, I guess I should say that 1 is congruent to 3 by the vertical angle theorem. Or if I can say that, and then I can say these are supplementary. So, and then I can say they're parallel. So let's try that out. We're going to try that approach. Might not be the best approach, but it is an approach. So we'll try it out. So the first statement I almost always use is the given, right? And that's that angle 1 is supplementary to angle 6. And we can only say what's given to us. Don't try to skip ahead and start saying that 1 plus 6 is 180. Because all I'm given is that they're supplementary. Now, I could say, because I know these are supplementary, I do know that the measure of angle 1 plus the measure of angle 6 is equal to 180 degrees by the definition of supplementary angles. And then, okay, so we're trying to get to here one of two things, I guess. Like I said earlier, either trying to get that 1 is congruent to 5, or that 6 and 3 are supplementary. And I kind of like the approach of 6 and 3 are supplementary because I know from vertical angles that 1 and 3 are congruent. So let's go ahead and say that. Angle 1 is congruent to angle 3 by the vertical angle theorem. And before I end up saying that, before I can just substitute in, because it's really tempting just to go ahead and substitute in 3 and for 1, I need to say that their measures are equal, right? If I've got an equal sign here, before I can substitute in, I need an equal sign here. So how can I say that the measure of angle 1 is equal to the measure of angle 3? What reason could I use for that? That's the definition of congruent angles. Definition of congruent angles says if I have two angles that are congruent, then their measures are the same. Or if the measures are the same, then the angles are congruent. Okay, so now that I have this, I know that 1 is equal to 3. I know that 1 plus 6 is 180, so let's go ahead and substitute that in. 3 for 1, measure of angle 3, plus the measure of angle 6 equals 180. And that's just by the substitution property of equality. Last but not least, well, maybe not last but not least, but we're trying, again, remember, we're trying to show that 3 and 6 are supplementary so that I can say those two lines are parallel. Extend this a little bit. And I know that angle 3 is supplementary to angle 6 by, again, the definition of supplementary angles. That's what a supplementary angle is. If they add to 180, then they're supplementary. And so since they're supplementary, I can say, what were my letters again? That line K is parallel to line I. Yes. And how can I say that? Well, I know that if same side interior angles are supplementary, that implies that the lines are parallel. And that's like really super shorthand, but that's okay. Same side interior angles are supplementary. That means the lines, that almost looks like lives, the lines are parallel. So that's a quick proof using these properties that we had talked about. And again, I took some time to brainstorm over here and just think about what could I use to say. And then right here, I only have kind of 4 things written out. But over here, we had to expand that, right? Make sure that each reason is solid. Oftentimes in arguments, you'll hear someone using a straw man argument, which just means that you set up the weakest possible, I guess, approach and then try to tear it down. This is a steel man argument, right? We're trying to set up a steel man that no one could take down and that there's no argument against. So hopefully this, again, helps you see how you can use parallel lines in proofs.